Welcome to Spring LIB.
Hi, today we will discuss about the motion of rigid bodies, and one of the common motions we see is the rolling of a wheel. So in case of rolling, you can decompose this motion into two separate motions. One is the motion of center of mass. We can call it VCM. This is the translational part. And there will be a rotation about the center of mass, and this leads to any complex rigid body motion. So you can always break the problem down into rotation and translation, and then you can study them separately. That helps you solve any kind of rigid body kinematics problems. Okay, so let us look at this problem of a wheel which is going, let's say, to the right, and there is, let's say, some velocity which is given as 48 miles per hour, and let us assume that the diameter of the wheel is 22 inches. So this is the information given to us, that velocity of center of mass is 48 miles per hour and the diameter of the wheel is 22 inches. Now, how about somebody asks us the velocity at different points? Let's say we want to find out velocity at this point. Let's call it point B. And let's also figure out velocities at some other points. Let's say the point which is touching the ground, point C, and then if this is vertical, then let's say we go at a 30-degree angle, then this is point D, and sorry, if this is the vertical, then point C should be touching the ground just below the vertical here, and let's say E is the point directly in front of the wheel here. So what is the velocities at these points? So to solve this problem, as I said, you need to think about separation in terms of translation and rotation. We know that a translation motion is basically a motion of all points of rigid body, which means that all the points in this wheel have the same velocity no matter where you go. This will have VCM, this will have VCM. All the points on the wheel will be going with a velocity 48 miles per hour. So this is the translational velocity. But if something is not at the center, then it will also have rotational velocity. So what is the rotational velocity? V rotational is given as omega cross r, where omega is the angular velocity and r is the radius vector joining the point to the point where you want to find the velocity. So let's take a special case. If r equals 0, which means center of wheel, so in this case, the v rotational will be 0 and v will be just v translational, which will be v center of mass, which is 48 miles per hour. Okay, but now let us look at some other points. So let us look at point C. So velocity at point C. What is velocity at point C? So velocity at point C will definitely be VCM plus now omega cross r. So since this wheel is moving right, what is the omega going to be? So omega is going to be in this direction because the wheel is moving right, and if you curl your right hand's fingers towards the direction of the arrow, you will notice that your thumb points inside this page. So the omega is going inside the page. So omega is going inside the page. And what is the r for this direction? So this is the right hand's rule for figuring out the direction of omega. So you curl your fingers towards the rotation of your body, and your thumb will point towards the direction of omega. So in this case, direction of omega is inside this page. Okay, so What is the R for C? So C is somewhere here in the wheel. So the R is actually, R is pointing downwards. So again, you can use the right hand rule. So if your vector, so recall the right hand rule, A cross P equals C. So for right hand rule, if you again take your right hand, and if your fingers are going towards from vector A to vector B, then your thumb will show you the direction of vector C. So this will be your fingers. This will be like fingers curling from A to B. So if your fingers are curling from A to B, thumb points towards C. So in this case, A is omega, B is R. So take your fingers down towards the page because that is omega, and curl your fingers towards where R is. So R is pointing downwards. So you first take your hand down, curl your fingers towards where R is pointing. You will see that your thumb is pointing towards the left because your hand will make a motion like this. If these are your fingers of right hand, and since your R vector is pointing here, your fingers will curl here, and initially they were pointing here because omega was inside the page. Just do it with your right hand and you will see that your thumb will tell you that velocity is going to be pointing towards the left. So VCM plus V rotational here will be, so VCM is 48. Let us assume that this is X, this is Y. So again, by right hand rule, Z is actually coming out. So you remember, this is the coming out direction and this is the going in direction. So this is plus Z, this is minus Z. So you can remember these directions like a pointing arrow. So if you have an arrow, the point of the arrow is pointing towards you, this is Z. And if the tail of the arrow is towards you, then on the tail of the arrow, sometimes you have these fins. So if you have shot an arrow into the page, then you can see the tail of the arrow and that tells you minus Z. So this is minus Z. Anyway, so velocity of center of mass is 48 miles per hour towards X. So this is I plus, now you can figure out the direction using this kind of intuition as well. But if your mathematics is correct, you will still get the correct answer. For example, here I'll tell you, even if I don't do the right hand rule, I can just write what is my omega. So omega is not given in this problem, but whatever omega is, let's just write it, omega naught, the value, and the direction is going to be inside the page. So this is minus Z, so this will be minus K cross R. R is in this direction, and we know that the diameter is 11 inches, so the radius will be, diameter is 22 inches, so the radius will be 11 inches. And then direction is going to be minus Y because it's pointing down, so this will be minus J. So you are going to get 48 miles per hour I plus 11 omega naught. Now minus minus cancel, and K cross J is minus I. So your final velocity is going to be 48 miles per hour minus 11 omega naught. Now what is this omega naught? So in this case, the rolling is occurring without slipping. That's what we will assume if it's a wheel of a car. If the car is not slipping, then the velocity is basically, the center of mass velocity is coming because of the rolling of the wheel. And in those cases, so in case of rolling without slipping, it's a mandatory condition that velocity of point C, which is touching the ground, should be 0. So this is something which defines rolling without slipping. So from here, if you impose this condition, now you get the answer that we see 0 just by remembering this rule. And you also get your omega naught as 48 over 11. So this was in miles per hour. This is inches. So we'll have to convert these units properly and cancel them out to make sure you get a correct number for omega naught. So how much is 48 miles in inches? Let's just quickly calculate that. So one mile is 63,360 inches. So it's, but let's, so 48 miles, 1 mile, as I said, is 66,360 inches divided by 11 inches. And this is, let's convert it into second as well. So 3,600 seconds in 1 hour. So let's see if we can divide this by 11. So 11 fives are 55. Then you get 8, 3. Then 11 sevens are 77. 6, 6. Yes, you can. So then 11 sixes are 7. Then 1, 0. Okay. So you calculate this number. Let's put this, so we can simplify it further. I think 12 fours are 48. Then 12 300 here, because 12 threes is 36. Then 1 0 can get cancelled. This can be further simplified. This is 15. This is 2. And so your final number is 2 6 are 12. 2 sevens are 14 plus 1 15. And then 2 fives are 10 plus 1 11 divided by 15. So the units are radian per second. Radians have no dimensions since we have cancelled all the dimensions. So this is this much many inches per mile. So the miles also get cancelled. Okay, so this final number will turn out to be, let's divide it, 15 sevens are 105, 10, and then 2, and then this is 15 sixes are 19, and then 10 is the remainder, and then yeah, so it will be 76.7 radian per second. Okay, so now we know our omega by imposing this condition. Now we can calculate the velocities of all the points. For example, let's draw this wheel again. We want to find out the velocity of this point, B. Sorry, B was here, I think. D was at a 30-degree angle. And this was actually point E. Okay, so what is velocity of point E? Velocity of point E is, again, as I said, all points in rigid body translate with the same velocity, center of mass, plus omega cross R. So omega, as I said, it's going down the plane, going down inside this page. So minus K, remember, omega is in this direction. So this is minus K, and omega is 76.7. And then this is radian per second. And then what is R? R in this case is going to point like this. So this is going to be R, since the radius is 11 inches, times 11 inches and the direction will be this time I, because it's in positive direction. Okay, so remember your VCM, that's 48 miles per hour. Sorry, this is just 48 miles per hour plus 76.7. Now it's useful actually to write this omega 76.7 just as 48 miles per hour per 11 inches, because you can cancel the inches in that case. So we again write 48 miles per hour over 11 inches times 11 inches I cross K, because K cross I minus times K cross I is actually I cross K. And so 11 inches and 11 inches cancel. This was I. Your final answer becomes 48 miles per hour I plus 48 miles per hour. I cross k is minus j. So it's 48 miles per hour I minus j. So the velocity is going to have a component in x, which is 48 miles per hour. It's going to have a component 48 miles per hour in j direction. So the net velocity, you use the parallelogram of law of addition. Net velocity is going to point somewhere here. The magnitude will be 48 times square root 2 because magnitude of I minus j is just 1 squared plus 1 squared equals square root equals square root 2. So this is why 48 root 2 miles per hour and pointing towards 45 degrees below the horizontal. Okay, so this is our VE. Let's find VB. So VB, so since velocity at the point touching the ground, VC is 0, you can imagine what velocity is going to be at point B, but let's just calculate it for the sake. So VCM plus omega cross R. So VCM we know is 48 miles per hour plus omega naught, as we said, is 48 over 11 inches, 48 miles per hour. What is the direction of omega naught? It's going to be the same, minus k going inside the plane, remember? And then R is pointing up now. R is here, pointing up. So R is cross. And by the way, I'm writing all this mathematically, but you can also use your right hand rule to figure out what's the direction of your velocity going to be. So in this case, it's going to be in positive x direction, but we'll just see it mathematically here. So R is pointing up, so it's positive j, and it's 11 inches. So 11 inches cancel, and minus k cross j is actually, so this is in I direction because velocity of center of mass or the translation velocity is same for all the points. So it's 48 miles per hour I plus 48 miles per hour. K cross j is minus I, then minus of minus I is plus I. So this is I. So this becomes 48 plus 48, 96 miles per hour I. This is true for any rolling motion. The point touching the ground always has the velocity 0, and the point on the top always has velocity 2 vcm, where vcm is the velocity of center of mass, which is the translational component of velocity, which is the same velocity of all the points of the rigid body. So this is a rule worth remembering. Then you don't need to do this calculation all the times. Okay, now let us look at the non-trivial one, which is at an angle 30 degree, the point D. Let's draw this diagram again so that you remember VD. So this is our wheel at 30 degrees. You want the velocity at this point. Okay, so again, it will Vd will also be velocity of center of mass plus omega cross r. So by the way, whenever we are doing omega cross r, you can see that the rotational component of velocity is always going to be perpendicular. So at this point, it was pointing downwards. At this point, it was pointing like leftwards. At this point, it was pointing rightwards. So these are all VCM components, which are the rotational. These are rotational components. So I should actually write them VR, um, VR, and VR. And then to find the final velocity, what we are doing is we are summing the rotational velocity plus translational velocity. So translational velocity is basically VCM for all of them. So in this case, it was VR plus V translational, which is VCM. Here it was VR plus VCM, which became 2 VCM. because what we found out is that VR for rolling without slipping is just omega r, which is just VCM. So because of rolling without slipping condition, all these rotational velocities in their magnitude are equal to VCM. So mod VR equals VCM, mod VCM. But remember that the direction is different. The direction is always perpendicular. Basically, direction is along the tangent to the point on the circle. And which part of the tangent? The part of the tangent which is basically, if you make your hand in a rolling motion, you can figure out what direction. Since the car is moving forwards and the velocity has to be accordingly. So you can figure out where the VR is going to point. It's going to be along the tangent. Since car is moving like this, it will be, the wheel is moving like this, the velocity will be pointing left. For example, here the VR will be pointing here because the velocity is here, and VCM will again be like this. So what will be the net velocity? By parallelogram sum, this will be the net velocity. Anyways, I'm just telling you the general rule. Let's come back to finding out the velocity at D. So this is VCM is 48 miles per hour times 48 miles per hour I plus omega cross R. Omega, as I said, is 48 miles per hour over 11 inches. And then R, in this case, you can break up R. So R is pointing like this at 30 degrees. So you can break it up. So R will be, if R is my radius, which is 11 inches, then this component will be cosine R, this component will be sine R. So you can break R into these two components. So the x component is negative, so it's minus 11 sine 30 degree I plus the y component 11 cos 30 degree, and it's a positive component because it's pointing up, j. So this is your R. So 11 cancels everything, and then basically we end up with 48 miles per hour. We can take it as common. Then we have I. Remember the omega was pointing down, so its direction is minus k cross this number. So plus, now 48 has been taken common, 11 has been cancelled. So it's minus k cross. Now minus sine 30 is minus half I, and then cos 30 is square root 3 over 2 j. Okay, so it's 48 miles per hour I plus, minus minus is plus, k cross I is j, so it's half j, and then k cross j is I, but there is a minus. So k cross j is minus I, but there is a minus here as well, so it becomes plus, and the value is square root 3 over 2. So k cross j is minus I, and minus again is plus I, so it's something like this. So it's 48 miles per hour, and root 3 is basically 1.73, and 1.73 by 2 is roughly 0.86. So it's 1 point, or let's just round it to 1.87 I plus this is half 0.5 j. Now let us check if this answer is correct from our intuition. So what will the cross product rule tells us? So I just discussed that at each point the rotational velocity is going to point towards the tangent here, VR, because the car is rolling like this, and VCM is always going to be in this direction. So this is VCM because translational velocity is VCM, and it's going to be same for all the points. Now if you add these two, the parallelogram law of addition will tell you that the final vector is going to be somewhere here. It has a greater I component than j component, which is true. both components are positive, which is also true. And so this tells you that the answer you have calculated is right. So this is how you can solve for any kind of rolling motion and find out velocities of different points. So points to remember is v translational, same for all points in rigid body. V rotational, if the body is rolling without slipping, then basically modulus of v rotational is going to be modulus of omega naught r, where r is the radius of the body, circular body, equals just VCM. So using these two principles, you can always solve for the final velocity, and velocity of any point P is going to be translational velocity plus rotational velocity, which is omega cross r. If you know the r for the P, you can always find out V of the P. Okay, see you in the next problem.